Hey guys, welcome to the second video in this series. I'm Indigestion, and today we're going to be covering the optimization of variables inside a script. To understand this topic, the first thing you have to know is that there are two types of programming languages. We've got compiled and interpreted languages. The former, so compiled languages, get their code compiled into something that's called binary code, and I'm sure you know what binary code is. So we convert all of the code to zeros and ones, and this code can be read directly by the computer. So you just change your code to zeros and ones, and then your computer can read it quickly. That's the idea behind compiled languages. Whereas interpreted languages are a bit more complicated. I'm sure you've heard of the Java interpreter before. So when we compile Java code, we convert it to something called bytecode, which is not binary code. It's some pseudo-binary code. And this code can be read by the Java interpreter. So we convert Java code to bytecode, and then that bytecode is read on runtime, so while we execute our application, by the Java interpreter, which executes it in the system. So the good thing about interpreted languages is we can convert our Java code to bytecode and execute that bytecode, which is universal for all systems in a Mac, in Linux, in Windows systems, etc. Whereas compiled into binary code languages can only be executed in the system for which they are compiled. So if you compile for Windows, you can only execute in Windows. If you compile for Mac or for Unix or Linux, you can only execute in those systems. So that's the advantage of Java over compiled into binary code languages. So what does this mean in terms of performance, which is the basic idea we're covering today? Well, basically, imagine you had a method inside your IMiner class. Actually, imagine you had a method inside your script class which allowed you to mine ores in any location. We don't have it, by the way. Imagine you just had that method inside the script. You would be able to call that method from your IMiner class, and it would work just perfectly. Well, depending on the coding of the method, of course. But if you had that method inside your script class, which is this one here, you could call it from IMiner. And that's because IMiner inherits all of the methods inside the script. So what this means is, if you call that method from your IMiner class, you don't have it created like the, for example, the mineOrs method here. You don't have it created inside your IMiner class. You would have it inside your script class. So what Java does on runtime is check for if that method you're using is inside IMiner class. And if it isn't, it checks for if it's inside the script class. And if it isn't, it checks inside scripts superclass, and so on. And all that takes processing power. And when you join everything together, then Java is slower than compiled languages. So interpreted languages eventually turn slower than compiled languages, especially in large programs. So what we're going to cover today is how to relieve the system from doing so many checks. So when you create a variable like booth ID we've got here, Java is constantly checking for if that variable is going to change, and it reserves memory space for that variable changing in the future, because that's just that, a variable. So why don't we tell Java not to reserve any memory space? Why don't we tell it that this variable is never going to change? Because it isn't. We're not going to change booth ID. We're not going to change OR ID. We're not going to change binding animation. We're not going to change styles to bank. Or that's it. We're not going to change any of these 4 variables. Or this one. So if we told it that, we would relieve some of the checks Java has to do, because it knows that these variables are not going to change. In addition to that, every time we execute a script, this is something a bit more abstract. So I'm not going to get into much detail. I'm just going to explain it in the basic terms. Every time we execute a script, an instance of our script is created, which takes up memory space. and that instance has these variables inside it. And every time we execute a script, that instance is created. And maybe if we have multiple instances of our script, we've got multiple instances of these variables, which takes up, each one of them takes up its respective memory space. What if we told it that since these variables are going to be the same for every instance of the script, so every time we execute our script, and maybe at the same time, these variables are always going to be the same, so they can be shared between instances. All of the instances can share the same variables. So basically what we're going to tell Java is that these variables here are not part of the instance, they are part of the class. So every instance is going to share the values for these variables. And I know you probably don't understand that, but trust me, it relieves Java from doing so many checks, and it will increase the performance. So to declare these variables as not variables, so as constants, we do the following. We specify that this variable is going to be final, so it's never going to change. And we can do that for these 4 variables. Actually, I don't know if this one does work. It seems, yeah. Didn't know if, since it was here, I don't know. Okay, so these variables are now constants, and Java has been slightly relieved from its work. And now we have to say that these are part of the class and not of every instance. I know that's difficult to understand, but the way we do that is we say it's static, but it seems this doesn't work on this variable. Sorry about that. Only on these ones. Notice now they've turned to the side. I don't know how to say that word in English, but yeah. So now these variables are constants, so they're no longer variables, they're constants. And these ones are static, which means that they are part of the class and not the instance. And now we should see, well, I don't know if we'll notice, but there should be a slight increase in performance. And the same way we can do this with the variables, we can do it with the methods. So all of the methods that are not going to change, we can declare as final. And so we're going to declare all our methods as final. No, we can't declare as final the onFinish, the loop, and the onStart, I don't think. Or maybe we can. Seems we can. I don't think I've never done that though. So I'll just leave it as is, just in case RSBot does decide to change the contents or something. Don't think it does, but who knows. Notice that mfillet does declare his variables as private and final. And actually we should declare our variables as private. And the anti-van as well, final. Under variables here at the top, private. And we declare them private so that Java knows all of the values are inside this class, and it doesn't have to check for superclasses for values of variables or anything like that. I know it sounds pretty unorthodox, but it's the way it is. Because all of these variables are only used inside this class, we can declare them as private. And finally, yeah, that's gonna be pretty much it. We could declare our methods as static. Actually, we can't do that. I think we can do that. No, actually, we can't. Sorry about that. We can't declare methods as static because we're accessing other methods that are not static. And yeah, I'm not gonna get into that. It's complicated to understand. So that's pretty much everything there is to optimizing your script. If you declare your variables and methods as private, Java won't check other classes to see if there are references to these variables and methods. So that's one check Java has to do less. If you declare them as final, Java won't check for if they change. And if you declare them as static, memory won't be taken when your script runs again at the same time. So those are 3 things you should keep in mind, and always declare as private your variables that are only used inside this class. Always declare final the variable that are not going to change, so the constants, and always declare static the variables you can to save up memory space. But we have another issue to cover, and it's the naming of the variables. Up to now, I've been using the camel case notation, which is the first letter. Every word is joined, and the first letter is lowercase, and then every successive word starts with an uppercase letter. And that's okay for variables, but for constants, there's another convention, which is naming the constants all in capital letters and words separated by underscores. So this will be props, and a lot of errors are going to appear. This would be booth ID, this would be OR ID, this would be mining animation, this would be task to bank. So final variables you declare like that, and now I have to go and check and change the names for everything. Notice that Java does differentiate between uppercase and lowercase. Okay, so that's it. I hope you guys do this in your script. Definitely useful. Yeah, and I hope you learned something. I know I didn't explain everything correctly. It's complicated to understand for the beginner, which is these tutorials are oriented to the beginners. So I know there's a lot of information missing. You can search for that if you're interested. And yeah, I hope you enjoyed it, and remember to subscribe and tune in for future tutorials. See you later, guys.